Hello everyone and welcome to my video. So my name is Abhijnyan Borah and today I will be guiding you through an important topic in mathematics. So in this video I will be explaining Laplace transform and showing you how to solve it step by step. So yeah, let's go through it. So at first let us see the topics which we are going to cover in this video. So at first we will cover Laplace transforms definition, then formula, then we will go through linearity property, then Laplace transforms of elementary functions, then some questions regarding Laplace transform, and at last first shifting theorem. That's it. So before discussing about Laplace transform, let's first discuss about transformation. So there are many kinds of transformation we know about, such as Laplace transform, Fourier transform, Z transform, and many more. So a question arises, why do we use these kinds of transformation nowadays? So there are many critical linear differentiation, partial differentiation. So in order to solve those problems, we use these kinds of transformation. So let us dig into the definition. Okay, so definition of Laplace transform. So yeah, let f of t be a function of t defined for all positive values of t, then the Laplace transform of f of t is denoted by Laplace f of t, or we can say f of s. Laplace sign is like this. Okay, so now the formula Laplace of f of t, or we can say f of s, is equals to integration 0 to infinity e to the power minus st f of t dt. So not only this formula, but we have to remember one condition, that is s greater than 0. So here the s which is present, that must be greater than 0. Okay, then only the integration is defined, otherwise it is not defined. The integration is defined. So the s may be, it may be complex number or a real number. May be complex number or real number. So the next topic which we will go through is linearity property. This is a small topic in which we will learn how to take out the constant out. Like, let's take if f1t, f2t, f3t, three functions, be any function of t, and let us take three constants, a1, a2, and a3 are any constants. So what we will get is Laplace of a1 f1t plus Laplace of a2 f2t plus Laplace of a3 f3t. What we will get is, we will take out the constants, right? So we will get a1 Laplace of f1t, then we will get plus a2 Laplace of f2t plus a3 Laplace of f3t. That's the. So our next topic is Laplace transform of elementary functions. Here we will learn some formulas and also do some questions. So let's start. We know the formula was Laplace of ft integration to infinity t f of t dt. This is the condition. So let's take an example. In place of f of t, we will take 1, then simplify it. Infinity minus st 1 dt. So let's simplify it. So we will get through this e to the power minus st divided by minus s. So the formula was 0 to infinity, upper limit minus lower limit we will do. So we will get e to the power minus infinity minus, then we will get e to the power minus 0 divided by minus s. So we know e to the power minus infinity is always 0. So what will get 0, then e to the power 0 is 1. So remainder. So overall we get 1 by s. So 1 by s is the formula. What we get is Laplace of f of 1 is 1 by s. Similarly, so next one, let's do it. The next formula will be, just take f of t is equals to tn. So we will get Laplace of tn equals to d0. So e to the power minus st tn dt. So this is a gamma function. So through gamma function there is a formula which we call like this, Sn plus 1. So this is the formula for gamma function. So what we will get is, through this we get the formula, this is n plus 1, so n plus 1. So we can take an example. Let us take Laplace of t to the power 4 now. So what will be, according to the formula, it will be n, so 4 plus 1, then here s 4 plus 1, it will be 5 s5. So what we got is this. Let us take another example, t3 by 2. Okay, so what we will get is 3 by 2 plus 1, that will be 5 by 2. So s5 by 2. So let us break it. We'll get 1 by 2. Then here we'll get s5 by 2. Yeah. This formula is also simplified. Then let's take another formula. Let's take f of t equals to e to the power at. So Laplace of e to the power at, e to the power at. So we will get infinity 0 e to the power minus st e at dt, right? So now through formula, we will get take a common here. Yeah, power minus t s minus a dt. So we took common. Now we will take e to the power minus t s minus a, then minus s minus a, then the lower limit, lower limit, upper limit. So overall we get 0 minus 1 minus s minus a. So what we're gonna get is 1 by s minus a. 1 by s minus a. So let us do an example. Yeah. E to the power 4t, 1 by, it would be s minus 4. Similarly, e to the power minus 5t, it would be s plus 5. Let us go to another formula. It would be 4, I guess. Yeah. So Laplace of sine 80, what would be? Let us do it. E to the power minus st sine 80 dt. So what we're gonna get here is, we will take e to the power minus st divided by the formula s square plus a square, then we will get s sine 80 minus a cos 80. So this is the formula. The limit will be there. Yeah. So now what we're gonna get is e minus sine t. So putting the lower limit and upper limit, we get here 0 minus, if we put here the lower limit, then yeah, it will be 1 by s square plus a square. Here it will be sine 0 is 0, so, and cos 0 is 1, so it would be a. So what we got is a by s square plus a square. So another formula, what we got is Laplace of sine 80 is equal to a by s square plus a square. Not sine, yeah, it's a by s square plus a square. So we got this. Let us implement it on an example. What we get is sine 40. It would be 4 by s square plus 16. Yeah, this is an example. So similarly, when we do cos 80, Laplace of cos 80, what we would get is a square, no, it would be s by s square plus a square. Yeah, this is the formula for cos 80. So let us do an example. Example would be Laplace of cos 70. So it would be s by s square plus 49. These are the formulas which we have to remember. So these are the most important formulas, as we would need it afterwards, it would require. So yeah, that's it. So this is the last topic of our today's discussion, that is first shifting theorem for Laplace transform. So this is the main formula for first shifting theorem. So let us try to do some examples through it. We will go to the definition, but let us first do some examples. So example, let us take out, find Laplace transform of Laplace of e to the power 2t sine 3t. So let us do it. So how to do this one? So here, in short, let us take out first Laplace of sine 3t. Let's take first Laplace of sine 3t. So what was the formula? The formula for sine 3t was 3 by s square plus 9. Yeah, this was the main formula. Then we have to then to the main coming to the main for main question. This one. So here it would be e2t. So there in place of s it would be s minus 2. So what it would be s minus 2 whole square plus 9. So this is the answer. Similarly, let us do another question. These are just I'm doing roughly. It's not like this is the format. No, this is the not format, but I'm just simplifying it to a shorter term. Yeah. E to the power minus 3t cos 2t. So let us do this. Cos 2t. So what did it be? S by s square plus it would be 4. Yeah, 4. Now then thus to the whole e to the power minus 3t cos 2t, then shall be the answer. It should be s plus 3 s plus 3 whole square plus 4. So this is the answer. So at last the definition would be, if f of s is the Laplace transform of the function f of t, then f s minus a is the Laplace transform of EAT ft, where a is real or complex number. So what it is said here, so if मतलब अगर एक f of s is the Laplace transform of the function f of t that we took here, f of t, f of s, and f of t for f s minus a, then the Laplace transform of EAFT where a is real or complex number, that is, like we have to write here, E f of t f of s, then Laplace of EAT f of t equal to f of s minus a. Yeah, that's it. So that was all for today. Thank you.